great to see you here again. My name is Luc de Custer, founder of the Custer Academy, and in this video I'm going to apply the PERT and the 3-point formulas or method on an activity on the node diagram. In the previous video I applied this on the original activity on the arrow diagram, the original PERT method. Of course we can use the calculations using the PERT formula or the 3-point formula. That doesn't really change the method. The moment we have an average or an expected duration or a mean duration and a standard deviation, we can apply that on the methods, on the different methods. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's have a look at the available data that we have. I mentioned this in the previous video also, but if you're only looking at this video, it's also good to repeat it here. Anyway, when we were using the arrow diagramming method, the ADM method, we used a fixed duration of the activities. We didn't count any uncertainty in it, and the results were not that good. So basically people saw when you have those events, the durations can vary, and we have to take these variations into account. And of course, averages, variations, we are going back to, yes, statistics. I know many people don't like statistics, but of course we are using it here in this method. When we looked at this, when we look back at the origin, we found that people were using a beta distribution and later a triangular distribution. The triangular distribution is typically used when we are not really certain that the duration of the activity follows a beta distribution pattern. Now we can use both of them. The formulas are a little bit different, and that's the only difference that we have here. Now when we look at the early methods, when we looked at these methods introducing uncertainty, we use the PERT and the 3-point formulas to calculate the mean duration of the activity, or the duration that we would have 50% probability to exceed or to be faster than that duration. And of course, we also found a standard deviation. And these are the things that are going to be added to the activity on the node schedule. So let's have a look at the schedule that we have. Here we have the different activities at the same diagram like we used before. We have 3 activities A, B, and C without predecessors. D has a predecessor A, E has predecessor B, and F has predecessor B and C, and finally G has predecessors D and B. Of course, what we don't have compared to the classical approach is that we don't have these dummy activities. Now let's add the duration and the standard deviation. We have it the same as before. Duration of A is 4.7 with a standard deviation of 1.5. For B, 2.3 and 0.5. For C, 1 and 0. For D, we find 2.5 and 0.8. For E, 3.4 and 0.8. For F, 2.3 and 0.2. And finally for G, 5.3 and 1.2. Now when we are using this and we are starting from 0, we can just use the same calculations like we did on the activity on the arrow method. So we start from 0, A starts at 0, finishes at 4.7, B starts at 0 and finishes at 2.3, C from 0 to 1, and now we can calculate the start and the finish times for D, which are 4.7, and 4.7 plus 2.5 gives us 7.2. We do the same for for G in this case first. We go from 7.2 because we have 2 predecessors, D and B, and we take the highest value, which is 7.2, and the final time, the end time of G is 12.5. We do the same for E, so we have start time of 2.3 and end time 5.7, and for F we find 2.3 and 4.6, which gives us a project duration of 12.5 periods. and this is the duration of the project. So that's starting from 3. So basically this is the starting point from which we can continue, and we will do that with some additional exercises. So let's continue in the graph, in the presentation. So when we look at the 3-point PDM starting from 0, we're using cardinal numbers. So like I showed before, we can find all these elements quite easily, and we can see that we can calculate the critical path very easy to determine this. And you see in the bottom graph, you see the 3 activities A, D, and G with a detail of the calculation. Now, when we go to a PERT or 3-point starting from 1, we cannot use those formulas anymore because there is a problem with the calculation and it would not lead to the correct result. So basically what we have to do is identify the duration of all the paths, and we have to select the critical path, which is the longest path, and then calculate its standard deviation. So you see the activities A, D, and G, and the calculation of the duration of the critical path. The next thing to do is to calculate the standard deviation. And once we know the expected duration of the critical path or the project, we can determine its standard deviation, but we cannot just add the standard deviations as such. We add the variances of the activities on the critical path and then calculate its standard deviation by taking the square root. And you see that here we have 1.5 to the square, 0.8 to the square, 1.2 to the square, which gives us a sum of variances of 4.33, which leads to a standard deviation of 4.33, and we take the square root of that, which is approximately 2.08. So that's it for this new presentation. I thank you for your attention. Anyway, before quitting, before stopping, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next videos. Bye bye.